Yeah, good. Shut up. Here we go. Aiden, let's talk about your test. So the test Thursday, it's got about 15 multiple choice questions. Most of those multiple choice questions are probably going to be using some variation of the equations on your formula sheet. In other words, I'll give you the voltage and the current, find the power. Or I'll give you the power and the current, find the voltage. Or Ohm's law and Joule's law. V equals I times R, P equals V over I, E equals, or P times T, I think energy is power times time, and then the kilowatt hours, and that's most of your multiple choice. Then there's going to be about 6 questions, Tristan, very similar to the take-home quiz from last class. Okay, I'll make them 2 marks each. You don't have to show work. You can go through them, but I would encourage you to show work. And then there's going to be, I think, 4 or 5 circuits to solve like this. That's your test. So you've all changed the 30 to a 20 because it makes it more interesting. This question says, what's the power dissipated? We want to find the power right there. Okay. Here's what we said. First thing I'm going to do is label which way is downhill. So here's my battery. That's downhill. That's downhill. I guess that way's downhill, that way's downhill, that way's downhill, that way's downhill. And Lena, here's the key idea. This is the bottom. This is height 0. And again, you're 24 volts high. If you end up back here at the bottom of the battery, you're 0 volts high. You've lost all your voltage. Current doesn't vanish. Voltage has to get used up as long as you keep going downhill. Then we said you're going to look for total current. By the way, what's current measured in? Units? Tristan? So I'm looking for, you know what? I got amps right here, 0.4. Is that the total current? Is the total current in this circuit 0.4? By the way, you might want your yellow sheet handy in front of you, right? The formula sheet. Is this the total current? Convince me. Someone said no, you're right. How come? Okay, there's a junction right here. Some of the amps, some of the current, what I've called skiers, could have gone down that hill. So I said, second thing I always look for, Nate, is total current. Don't have it. Third thing, anywhere they told me 2 things right here. This is how I'm going to solve this. I'm going to start right here. So they told me current. They told me, what's that 30? Resistance. So that means, you know what? I can find that. I won't do this in red. I'll do it in blue. How many volts do we lose going through that particular resistor? How do you figure that out? Do you guys know? I hope you know, because this is supposed to be... What's this? Current? What's this? Pardon me? Yeah, we changed that to 20 a while ago. Yeah.
No, but the other one.
No, I just changed this one to make it a different question. I'm not, what are you asking me? Like, scribble that out, make that a 20.
Yeah, but what about the other two?
I'm not changing that. I just wanted to make it a different question. I cut and pasted a question, and I had to make a different one. Okay, sorry. You with me now? How can I find the voltage here? What equation am I going to use, folks? Yeah, V equals I. Can you do that on your calculator? How many volts must we lose going through this resistor? How many volts must we lose going through this resistor? Someone crunch it. Folks, by the way, can we not take 80 or seconds or 200 seconds? Crunch it right away. What do we get? Louder? Okay, 12 volts. Okay. Is that enough to help me figure out this question? Well, if I ski this hill, that one there, if I ski that circle, if I start at the top and end up at the bottom, always going downhill, there's 2 hills. I don't know the voltage. I don't know the voltage here or here. So that doesn't help me yet. What else do I now know? Right here is a junction. Some current went this way. Some current went that way. How many volts did we lose going this way? 12. So how many volts must we lose going this way? Why? Because if you shake hands at the top of a hill, and you go that way and I go this way, and we meet up at the bottom, the voltage must have been the same. This also has to be 12 volts. Now, why is that so handy? Because now I know two things. Yeah. Nice and loud, I can't hear you. I just changed all I did was change the question. I didn't like it when I photocopied it for you, so please scribble out that 30, make it a...
I did.
Yeah.
I asked the same thing. It doesn't matter?
Those are just the values in the... I'm not sure what you're asking. I cut and pasted a question from a different document from your homework, and you've already done that question. So
Why we changed it.
to make a different question. Otherwise, I'm doing a homework. All I did was just make up a different question by crossing out one resistor, changing the number. Now it's a whole new question.
Okay, so the resistors are different then.
Yeah. Otherwise, they were both going to be 30s, and it was going to give you a boring question. So I changed one number. It's all nothing, not for any physics reason. I just wanted to come up, because this one shows up later on in your homework somewhere. So I went, oops, I forgot to change. By the way, you can see in most of these, I scribbled out the numbers, Rihanna, ahead of time to change it. Look up. I scribbled out stuff ahead of time. I forgot to on that one. So that's why this morning when I was, should have changed that too. That's all. Okay? You okay with the 12 volts then from here to here? Because if you get from here to here or from here to here, you have to lose the same voltage. What else can I find here? Yep. Current. How can I get current? Current equals what as an equation? Current equals what as an equation? Find it fast. V over R. So V is 12, R is 20. How many amps go through this resistor? How many amps go through this resistor? Crunch the numbers. How many amps go through? I'll get to you in a second. Crunch the numbers, people. Can't take this long. If you don't have your calculator out, you're not following along. Get your calculator out. Can you go V 12? Come on in. I'll get you later. Come on in. Yeah. 0.6. Is that right? Okay. You guys are making this last a lot longer because when I ask a question, there's like 90 seconds before somebody types it in. Type it in right away onto your calculator. Okay. So ready, Mateo? How many amps went this way? You just told me. How many amps went this way? The question told me. How many amps went this way? How many amps went this way? How many amps are right here? Yes. How many amps are right here? How many amps are right here? 1. How many amps are right here? Ah, nice. Follow that? Now, why is that so nice? What did this question, Mateo, ask me to find? Power. In which resistor? We're doing the practice circuit sheet from last day. In which resistor? In which resistor?
Oh, 500.
The 5 ohm, right? Don't overcomplicate this.
Yeah.
In which? That one. Okay. What do I know in this bottom resistor? Do I know power?
Yeah.
Not yet. Do I know current? Do I know resistance? Please tell me there's an equation that has power and current and resistance in it. Thank you for getting your yellow sheet out.
V equals R squared times.
Okay, no talking, guys. What's I in that resistor? 1 squared. What's R? Yeah, you know what? I can do this in my head because 1 squared, what's 1 times 1? Times 5? You know what? Here it is. The power in this resistor is 5 watts. There it is. This is this hopscotching approach. You got it okay? Yeah? This is a couple more, we're done. Number 6. Number 6, looks like they want me to find that thing, because that's where a variable is, but no number. All right. Which way is downhill? See the battery? Which way is downhill? Left or right from the battery? Okay? That way. So let's fill this in. That's downhill. That's downhill. I guess up is downhill here, down is downhill here. What we're really saying here, Jordan, is right at this junction, the current splits up. Some goes this way, some goes that way. Doesn't split up 50-50. It might, but it might not. I don't know. I can't make that assumption just because there's, half will go that way, half will go that way. Keeps going, keeps going, keeps going, keeps going, and it meets up here. Oh, and they even gave me the current going that. Oh, they gave me total current. What's the total current in this resistor? 5 amps. That doesn't mean that it's 2.5 amps up here and 2.5 amps down there. Might be. I don't got to prove it. So I know total current. Is there any resistor where they told me 2 things? Nope. So what was my strategy? Figure out which way is downhill. Look for total current. See if that helps at all. Look for 2 things. No. The last thing, go skiing. How high am I right now leaving this battery, leaving this chairlift? Okay. I'm going to ski through the resistor that I know. Did that get me back to the bottom? How high was I when I left the chairlift? How many hills, how many resistors did I go through? So how many volts must I have lost going through that resistor? Has to be. Has to be. Why is that so nice? Now I know 2 things. I think I can find the current here. I know the voltage. I know. Oh, you know what? I can use this thing. Mateo, how many? Did you say the? I thought you said the answer. 2. You okay with that, Kyle? Okay. By the way, how many amps are... Sorry, guys. How many amps are there grand total in this circuit? 5. How many amps went this way? How many amps had to have gone this way? 3. Do I know 2 things in that bottom resistor? Not yet. Oh, I do know one more thing. Does anybody see what else I know in that bottom resistor? Volts? How many volts does the bottom resistor have to be?
28.
Also 28. Why? Because if you can go this way or you can go that way, you must go through the same height. If you break up at the top and meet up at the bottom. So this is also 28 volts. That's enough for me to figure out the resistance. Please tell me there's an equation that has the R by itself and a V and an I in it. There is.
R equals V over I.
Right? Good. Do that on your calculator. V, 28, over, divided by I, 3. What do you get?
9.3.
I'll put a box around that. There. Okay? I would consider this question here a B- level question. This is already tricky. If you're getting the hang of this, be proud. Yep, not an A+ level, not a C- level, not a C+. This is already we had to do 3 steps to get, this is a 3-step question. But if you don't panic, if you go just keep hopscotching and keep falling back, skiing, you should be okay. 2 more. I think, let me see here. So here they want you to find the power in that resistor right there in watts. I'm going to give you a little bit of a hint on this one. Here is where they told me 2 things. It didn't photocopy great, by the way. Does yours actually have a line right there or not?
Well, it's segregated.
Yeah, okay. Mine totally vanished on my copy here. So make sure you understand there is actually a wire connecting that right there. How would I tackle this? This is where they told me 2 things. I think it's going to fall apart. I'm going to let you try number 7 as part of your homework. And then number 8 says find the current through the 6 ohm resistor right here. How would I solve this? Kiana, here is where they told me 2 things. I think that's going to help me get it to fall apart. So your homework, try 7, try 8, and work your way through this. On Tuesday, all I want to do is take questions from this, but I don't want the questions to be, Mr. Dueck, I didn't start it. Try this. I'm going to give you the rest of class. I was hoping to give you half an hour. Oh, yeah, you are going to get 35 minutes, actually. What I would love to on Tuesday is, Mr. Dueck, I got most of number 6, but I couldn't get the voltage in the 3rd resistor. Or Mr. Dueck, I got most of number 8, but I couldn't get the power in this resistor. So that's what I want you to work on for the remainder of class. Okay? As I cough up here and continue to hack through my cold. So I've been asked to do some of these. Basically, I'm going to start solving as much as I can, and then as soon as I find 2 things on the mystery resistor, then I've got the power. All right. Did they give me total current anywhere? What I mean by total current, guys, can you be a little quieter? Sorry, a little whispered. Total current would be any of those wires, not on any of the junctions. Do I have total current there anywhere? Nope. Then I look for, well, downhill, that way, that way, that way, that way, that way. I'm looking for anywhere where they told me 2 things. I'm tackling this right here. Okay? That's where they told me 2 things. On resistor number 2, by the way, someone said, what does that 2 mean? Am I supposed to double? No, that's just saying resistor number 2 and current number 2, as opposed to resistor number 1 and current number 1, as opposed to resistor X, mystery resistor. Okay? It's a handy way to keep stuff organized. That's the resistance. That's the current. What's the voltage? Sorry? How'd you get that? I times R. Yep. Okay? Now, what does that tell me? I'm going to, well, first of all, since we shake hands here and split up here, I now know the voltage up here too. What? 1 volt. I now know 2 things up there. I can tell you the current up here as well now. I think, is that one V over R? 0.2? Why is that so nice? Because if I have 0.2 amps in the top resistor and 0.1 amps, which is what they told me, in the bottom resistor, how many amps right here? Yep. How many amps right here? How many amps right here? How many amps in the mystery resistor? 0.3. I said if I know 2, I know 4. I'm halfway home. Now what? Let's go skiing. What I mean by go skiing is always going downhill, start from your battery, and end up back at the bottom of the battery. By the way, how high is the battery? 5.8 volts. How many volts do I lose going through here? Don't know. How many, you want to go through the top one or the bottom one? Doesn't matter. Pick. How many volts do I lose going through here? Did I get to the bottom? Well, if this is 5.8 volts, and I lost 1 volt, how many volts do I have to lose going through here? 4.8. And I'm done. Almost. Because I know 2 things. You know what? As soon as I know 2, I know 3 or 4. I can find anything else. What did they want me to find in that resistor? Read the question. Power. There's V, there's I. Please tell me there's an equation that has P and a V and an I in it. You know what? It's going to be whatever 4.8 times 0.3 is. 1.44 watts. Okay. That's a very small little LED bulb or something like that. If it's, you know what? That's probably not even a light bulb, but something else. Is that okay? Or they could have asked me to find the resistor, because the resistance would be V divided by I. If they had said find the resistor, it would be 4.8 divided by 0.3. They didn't ask for that, but what you said, I could find the resistor. Yeah, sure could. Okay? Is that all right? Do number 8 together. Let's do number 8 together. Downhill. Downhill. Downhill, downhill, downhill. But it splits up into 3 ways this time. And downhill. Right now, I'm staring at, ding, 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 they told me 2 things. You know what? I know that. Yep. How many volts do I lose? More specific. It's 3 times 4. You shouldn't need a calculator. By the way, the reason we do that, I took this from the Physics 12 provincial exam, and just the standard is they go to 2 decimal places with almost every number. Yeah. I stole these. I'm teaching you guys Physics 12. Yeah. Yes. So far, so good? Now, how many amps right here? How many amps right here? How many amps right here? 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 Here. I know 2 things. Stop. I know 2 things. You know what? I also know the voltage drop going through there. Yeah, in your head, please. It is 16. Now, this 4 amps splits up into 3 chunks. They're not going to be equal. By the way, if all 3 of these, Rihanna, this answers your question from earlier. Look up for a second. If all 3 of these resistors were identical, the current would split in 3. That's why I changed that 30 from a 20, because I didn't want the current to split in half. So if you're wondering, why did I scribble this out? I didn't like the question because I didn't want you to think that the current always split in half. It doesn't. It splits. It only splits exactly in half if both resistors are identical. Now I can answer your question properly. Hey, let's go skiing. That's my other fallback. So, starting at the top of the hill, and I'm going to go through the resistor that I'm trying to figure out. There's a loop. There's a ski hill. How many volts high do I start? So I better lose 40. How many have I lost here? How many have I lost here? There's only one other hill. How many volts must I lose there? Can you get the headphone out of your ear, please, Aiden? Can you please do the math? You have a calculator. It's going to be 40, take away 16, take away 12. I don't want the, I think, either in your head for sure or calculator for sure. It's going to be 40, take away 16, take away 12, whatever's left, right?
24 minus 12.
Is it 12? Why is that so nice? Now I know 2 things. This question said find the current right there. I can find the current right there. It's going to be V over R. It's going to be 12 over 6. It's going to be 2 amps.
Do you have to do the 10 and the 15 section? Like you have to like
Nope. Nope. For what it's worth, how many volts from here to here? How many volts from here to here? Also 12. How many volts from here? Also, because you're shaking hands and meeting up. Each hill is the same height. They'd all have different currents in them. But these 3 would add to 4, because there's a total of 4 amps. Let's go to the solving circuits homework. Let's start working through some of these. I think there was only up to number 8, right? What did the question want you to find? We answered the question. Oh, there's a number 9? I stand corrected. Oh, there is a number 9. Let's do number 9.
In the following circuit, determine the value.
Okay, now we're finding R. Okay. First thing I would check, did they tell me total current anywhere? I don't see anything with amps. So, nope. Oh, and then I would also label downhill. Okay? So, Rihanna, downhill is that way, right? That way. We split up. That's downhill, that's downhill. Downhill, downhill, downhill. So when I draw my ski hill, that's the direction that I'll go when I go in a loop. All right. Second thing I always look for, anywhere they told me 2 things. Is there a resistor where they told me 2 things? Right there. Well, then I know 3. In fact, I know 4. But what I'd like to find, they gave me resistance, they gave me voltage. I kind of want to know the current. Can someone crunch that for me, please? How can I find the current? V over R. So it's going to be 5 divided by 6. What point? 0.83333. So I'll carry a few extra decimals because I want my other answers to be more accurate. So I wouldn't go 0.8, even though that's technically right to 1 decimal place. I'm going to go 0.833. I'll carry a few extra because I know I'm going to use this to find other stuff. Right? Does that mean there's 0.8333 amps there? No, because there's also some current coming from this junction. What other trick can I use? Well, how many volts going down this hill? Resistor. How many volts going down this resistor? Has to be because we split up and met up.
What happened to Dan?
You move back there. Good to see you're observant. You okay with how we found that, Leah? Okay, what we're saying, anytime you split up, look up, Mateo, anytime you split up and meet up, whether you go this way or that way, the only way that's possible is if you start at the same height, same voltage, and end at the same height, same voltage, which means you must have lost the same voltage. 5 volts, gotta be. I now know 2 things in that middle resistor. What's the current there? Amps. Is that okay so far? So here's my question. What's the current right here? What's the current right here? Well, how many are coming in this way? Current. How many are coming in this way? Add them up. That's going to tell me the current right there and in here. So it's going to be 0.83333 plus 1.6666. I think it's supposed to be exactly what? It's 2.5, right? Yeah, it's got to be 2.5. We found one thing. Kiana, we need to find something else. Now what? Let's go skiing. Yep. Well, we're going to go skiing first to figure out what the voltage is down here. Sorry? Here? Okay, so I'm going to show you why that can't be right. If you said this, what you're saying is, how high are you right here? Look at the battery. How high are you right there? How many did you lose here? 5. How many did you lose here? 5. You can't get to the bottom. You still have 8 volts left. That has to be wrong. Can't be 5. What? Has to be 13. No, I equals Mr. Dueck. Good, now find the resistance. Is it 5.2? B, if this was a multiple choice question. Hey, let's try some of the homework. This thing. I'll start working through it. They get tougher as we go, but if you wrap your brain around the basics, then all that happens is it's more hopscotching. But I handed this out a few days ago. This is what you want to be working on. Yeah. You get up to 6? And you're getting the right answers, looking in the brackets, because I put the answers in the brackets and they're working?
Yeah.
Oh, good. Which one do you want to start on then? Yeah, I'm totally in. Okay. Find everything. Anywhere there's an equal sign, put the number next to it. Yep. For the written section, for the circuit section. Yeah. In fact, although I think on the test I made it obvious, I even put a little line right there. I think I drew that in too. All right. Here we go. Find everything. Well, that's downhill, 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 downhill. You guys okay with how I'm, right? I just go look at the battery, and the longer line is positive. And current goes from positive to negative, even though electrons flow the other way. Ben Franklin named these wrong, but it's much nicer to deal with positive numbers. Did they tell me the total current anywhere? So now I'm looking for anything that has an A next to it, right? The total current is 2 amps. Now, here's the key. The reason I know this is the total current is if I backtrack to here, there was nowhere else for the skiers to go, and everybody goes through the chairlift, the battery. Okay, so how many amps right here? You just said it. Splits up. But when they, how many amps went this way? How many amps must be gone this way then? Must have been also, there's your 4 amps. Okay? That's where, look up, that answer came from. If you wanted to cross out answers one at a time as you find them, you can, whatever. Okay? So how many amps right here? Right here? 4. How many amps right here? Here. I can cross out that. Now they want me to figure out this voltage and this voltage. To find voltages, if I don't know 2 things, I ski. Now, look up. I don't want to ski this circle because there's 2 hills that I don't know. But if I ski, ready, Amelia? How high? What do I lose here? Don't know. What do I lose here? Leaving? 8. What do I lose? Oh, you know what? If I lose 4 volts, how many volts high must this be so that I lose my full 12? Now, we could either figure that out by skiing this run, or we could use the trick of saying if you split up and meet up, you must have gone through the same voltage drop. Okay. Let's try a yuckier one. Let's try number 9. Oh, you know what? Let's try number 10, because it says this one is nasty. Okay. Well, downhill, 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 downhill. Boy, those arrows look terrible. Now, I see amps all, because remember I said we look for total current? I see amps all over the place. Are any of them all of the current because everything had to go through there? I don't think so, because some of the current could have gone this way. So total current's not 4. Total current's not 5, because some... Oh, wait a minute. Did we split up and meet up? How many amps went this way? How many amps went this way? How many amps right here, then? How many amps right here? 7. How many amps down below? How many amps up above? Oh, how many amps right here? How many amps right here? And that is the total current. I told you, if you find the total current, it's going to fall apart. This is going to fall apart now. Oh, you just made my little math nerd heart go pitter-pat. All right. Voltages. How far from here? How many volts? Amelia, what? 10. Has to be. Why? Because same as that one. Well, I don't know either of these hills. Apparently the answer is supposed to be 43. Let's prove it. Let's go skiing. Because my final step, I ski a run. So, how high are we starting? 55. What do I lose here? Leaving? 53. Let's go down this one. What do I lose? Leaving? Now let's go through this one. Did I get to the bottom? And I only went through one more resistor, one more hill? It's got to be. And then I can use that split up, meet up trick. These are kind of fun. Well, they're little.
I get it a bit more.
I can keep going. There's still time. And I'll do this also on Tuesday. Let's see, which one looks really yucky? Let me see if there's a really ugly one. Sorry? I was crossing out answers as we went. I think I filled in every blank. I didn't ask, by the way, I could have also asked you to find resistances. Well, so for example, Mateo, this right-hand guy here, R equals V over I. That's a 2 ohm resistor. This is a V over a 5 ohm resistor. Yeah. No, I'm not going to give you the answers on the test. Sorry. Nice try. Well, on the multiple choice section, sort of. Which one of these looks really, really...
Maybe 14.
14? Sure. 14. What was the hint? Yeah, okay. 14. Downhill, 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 downhill. We're going to go this way. Okay. That's total current, isn't it? Because that's what goes through the chairlift. It splits up here, but you know what? Right? By the way, in each of these resistors, I now know 2 things. How many volts do I lose in this top resistor? I times R. It's going to be a decimal, so please do it on your calculator. Do you have your calculator here? Okay, then I'm going to have to do it for you. Bring your calculator on Tuesday and on test day. Apparently 35.82 volts. And in the bottom one, well, the bottom one I can do in my head because it's timesing by 10. 2.985 times 10, 29.85 volts. Right? Is there anywhere else where they told me 2 things? And I can't assume, because these resistors are different, I can't assume that we just split up in half with the current. So, we ski. How high? 80. Jump, and I'm going to go through the mystery one. How many volts must be in the mystery one? I start with 80. What do I lose here? What do I lose here? Whatever's left. So tell me what to type on my calculator, please. Since you didn't bring one, what am I going to type? I'll give you a hint. 80 minus this has got to be 14.33. Now they wanted me to find power. Do I have an equation that has power V and R in it? I don't think I do. Oh, wait a minute. Could I find the current right there? Because then I can use, I think, that one. So how would I find the current? V divided by R. This number divided by 8. The current there is 1.7912. I'll write down 1.79 amps, but I'll keep this number on my calculator because that way I can use my answer button. So the power is going to be V times I, and I'll use my answer button rather than retype it because it's less work. 25.7 watts. Please tell me that's what the answer says. I hope. There you go. Oh, yeah, 25.668. You know what? We round off a little bit. Now, if I gave this to you, Aiden, on the test, I would actually have put a letter P equals and a blank on there somewhere, or somewhere I'd have a spot for you to actually put the answer. I was making these in a hurry from old provincial exams that I didn't have time to do the formatting properly. And Rihanna, in answer to your earlier question, this is why I don't use the textbooks for this unit. It's so much handier to be able to draw. I used to, when I first taught Physics 12, my kids would have to copy out the circuits. I mean, copying out each one took age, but you can't solve them in your head. You can't solve them without drawing on them. You really can't. So that's when I kind of started typing my notes up. You'd notice I do that most of the time. I'm going to pause there, but I think you got that help, I hope? Yeah. Okay? So, folks, I didn't want to give you homework over the long weekend. Try some of this over the long weekend or get it done in class.